Hello, good morning everyone. So my name is Lakshay. I welcome you all to the discussion of AIATS Plus Mock Test 6. The paper was conducted on 23rd of Feb 2025. Okay, here in the very first slot we will be dealing with the organic section of this paper and specifically for the 12th portion. And the chapters were alcohol, phenols, ethers, aldehyde, ketones, carboxylic acid and amines. So let us start from the very first question. Okay, very good morning Dashut. Okay, let us start from the very first question. We having the compound which will not give carbylamine reaction. So before going with this reaction, we have to understand what are the reactions which are dealing with the chloroform. So in that portion, we will cover the three main name reactions. Which are they? The first one is a carbylamine, second one is a Riemann-Tiemann reaction, and the third one is the haloform reactions. Okay, so we all are dealing with the chloroform reactions. Okay, then we will come back to the question part. Okay, let us start with the very first approach. Let us see, you are having chloroform. We can say that the chloroform reactions. The reagent is chloroform, CHCl3. The first and very basic reactions we are gonna do is carbylamine. We can characterize it in the form of carbylamine and Riemann-Tiemann. Riemann-Tiemann reaction. And the carbylamine is specifically for amines, or we can say that it is specifically for 1 degree amines. And in the same way, Riemann-Tiemann reaction is applicable for phenols. So let us start these two reactions in very much detail. And the third reaction, we can say that haloform reaction, in which the chloroform, or we can say that the iodoform or haloforms are the product of the reactions. Okay, so we will be going to the depth in the later part of this session. So we will back to continue. Okay, now we are having the first reaction, which is carbylamine, or we can say that if we are having aniline, let us take in substrate called aniline, and we are dealing with carbylamine reactions. Carbylamine, this is carbylamine reaction. So in this reaction, the aniline, we can take it as a substrate and we are reacting it with chloroform in the presence of an alkali called KOH. What will you get? This is the product. We will try to identify by using the mechanism, then we will write down directly the product formation. Okay, so let us go to the mechanistical approach of this reaction. We are having, let us say, in this reaction the substrates are chloroform, CH, we can write it like in a form Cl, Cl, Cl. We are reacting with base. Let us take it in the form of ionic form. We are having OH minus. So what does OH minus will go? OH minus will take a proton. It will take a proton and yield C, Cl, Cl, Cl and negative. After this it will undergo alpha elimination and the release of Cl negative takes place, yielding to the formation of carbene. We can say that it's Cl, Cl, these are this. And this carbene is not that much stable, but it is stable due to the presence of lone pairs on chlorine as well as the vacant orbital present in the carbon. So there will be the plus M donation from chlorine to carbon. Okay, so this is very much stable, or we can say that this is a type of carbene. Which type of carbene? This is of singlet type of carbene. Okay, let us move to the next portion. This is the step 1. We can say that we have generated an electrophile during the reaction. This is electrophile. This is the role of reagents while doing with the reactions. Okay, so After this, we are having a substrate. What is it? We are having aniline. This is step 2. We are having aniline. So what does aniline will gonna do? Nitrogen are having the lone pairs of electron. So can I say that this aniline will act as a nucleophile and will attack to the electrophilic center? Obviously yes. So what will it gonna do? It will have this electrophile CCl2. This is the electrophilic nature. Do not confuse these radicals via lone pairs. These are not lone pairs. So these lone pairs will undergo will attack to this position, or we can say that electrophilic reaction will occur and will yield an intermediate, or we can say that in transition state called NH2 positive and CCl. You are having CCl2 and the negative charge will occur. There will be having the negative charge. So what will it occur now? This negative charge will abstract a proton from this amine and will have, when we are having, just a second. And we are having this NHCCl and this hydrogen from nitrogen to this will occur. And then what will occur? We can write it in the form like this is N, this is C, Cl, Cl, presence of lone pairs. Also there will be the hydrogen, there is a hydrogen. So the lone pairs of this nitrogen will remove an chlorine from this and you will be having called amine. This is N, double bond C, Cl, H, H, and the positive charge will occur. And the Cl negative which were already released will abstract this proton and you will be having this N, double bond C, Cl, and H. And again, what will be the reaction? There is also presence of lone pairs again. So this lone pair will again undergo and release the Cl negative again, and you will be having a product called N triple bond C. The positive charge comes over the nitrogen and the Cl will remove and you will be having the hydrogen. The Cl negative removed will take this proton, or we can say that there is the presence of basic medium will abstract this proton and you will be having this is N triple bond C. We can say that there will be the presence of triple bond C, positive charge is already here and hydrogen is there. The OH negative will abstract a proton from this and you will be having OH negative or Cl negative and you will be having N triple bond C negative positive, and we can say that this is isocyanide. This is isocyanide. We can also say that carbylamine reaction is also known as isocyanide reactions. It means the product formation in the carbylamine must be isocyanide. So this will be the case when you will be having only 1 degree amines, and this reaction will not occur when there will be no 2 degree or 3 degree amines. Okay, so this is the product formation in the carbylamine reactions. Good morning, everyone. So the product formation in the carbylamine reaction is isocyanide, and this is very distinct smell over this. The smell of isocyanide is very foul smell. You can identify it. Okay. Namaskar. Chalo. Let's back to the question part. Then we will be back again to the Riemann-Tiemann reaction. We are having yes, the question number 81. the compound which will not give carbylamine reaction is. We have already undergone mechanical approach regarding these reactions. Only 1 degree amines can undergo a carbylamine reaction or isocyanide test. Okay. So what will be the answer of this reaction be? Aniline. Aniline is 1 degree aromatic. It can undergo a carbylamine reaction. Benzylamine. Benzylamine, the structure of benzylamine is this. CH2 and H2. This is also a 1 degree amine, so it can undergo carbylamine reaction. The next one is N-propylamine. N-propylamine is like this. This is also 1 degree, so it can also undergo carbylamine reaction. And in the fourth, you will be having triethylamine. So we can write it in the form like C2H5 3N, and this is 3 degree amine. Yes, Vaishnav, this is AIATS question discussion bhai. And in this fourth part, this is 3 degree amine, so it will not undergo a carbylamine reaction, which makes our answer number 4 a valid answer. I hope this question is clear to you all, everyone. Is it clear? Absolutely, Jaydev. 1 degree aliphatic and 1 degree aromatic amines can give this test, carbylamine test. Okay, let's back to the Riemann-Tiemann reaction. We are doing the carbylamine reactions. Then now we are having the Riemann-Tiemann reactions. These are more or less same with the carbylamine reaction, but the only difference is the product formation. The way to approach the product is way more different than the amines. Okay, let's get back to the substrate portion. In this portion, in Riemann-Tiemann reaction, we will be having a phenol rather than amines. Right. So we can take a phenol. We are having this phenol over there. And again, we are reacting with the same. We are doing the chloroform reactions. We have to react with chloroform CHCl3, and the medium is also basic. It's already same. Let us take NaOH. So what will be the product formation we will be gonna do after the mechanical approach? Okay. Now we are having base. So what will it gonna do? See, you're having step number 1. This is again the same as we have already done in the carbylamine reaction. You're having CHCl3. You're reacting with base OH negative. OH negative will abstract a proton and will give you CCl3 negative plus H2O. And this CCl3 negative will again undergo an alpha elimination and will yield an carbene, CCl2. You will be having carbene. Absolutely. Phenoxide to salicylic, absolutely correct. And electrophile is carbene. CCl2, it's not positive, it is CCl2 only. Okay. So this is the electrophile of this reaction. This is the electrophile of this reaction. And also, when we are gonna do the step number 2, there is a phenol, and also the medium is basic, and that medium is that much basic that it can abstract in this acidic proton, and we are having base, so it can abstract this proton, and you will be having a phenoxide ion, O minus Na plus if you are taking NaOH. This is the phenoxide ion. Now, this phenoxide ion will act as a nucleophile, and the carbene is an electrophile. So nucleophilic electrophilic reaction will take place, and you will having, this is O minus Na plus along with CCl2, this is an electrophile and this is a nucleophile. So this, in this part, this O negative will not gonna undergo reaction. This will resonate itself. This carbon is having more electron density, so this carbon will attack. This will not occur. I hope this point is clear to you all. In carbylamine reaction, directly the NH position will attack to this electrophile, but in Riemann-Tiemann reaction, this carbon position is more nucleophilic to attack to the carbene. This is the clear difference between the carbylamine as well as the Riemann-Tiemann reaction. I hope this point is clear to you all. And then what will you get? You will be having O minus CCl negative. You will be having a negative charge here. So sorry. The double bond is here. And after this, now the aromaticity of this ring is disturbed. So what will it go? This hydrogen, it will taken by this and released, and will again the system get back to the aromatic one. You will be having this phenoxide ion again, CCl, ClH. And now what again will be the case? The O negative will come over again. This will go over here and Cl negative will remove, and you will be having double bond O, double bond C, here Cl, and now it's H, double bond, double bond. We can also say that the aromaticity of the compound is already gone. So in order to come back again, now it will not have any chance that there will be no hydrogen here. So what will occur? Now the OH negative, now the OH negative in the presence in the medium will attack to this position. It will come back to over again, and you will be having O minus CCl OH hydrogen, this and this. I hope this point is clear to you all. And then the one carbon is having the more than one substituent. So this O lone pair will come to the carbon and release of Cl will takes place, and you will be having kind of on workup as well. You will be having a salicylaldehyde. This is a product formation. I hope this is clear to you all. Is it? So in carbylamine reaction, the isocyanide will form. In Riemann-Tiemann reaction, salicylaldehyde will be formed. Is it clear to you, everyone? Okay, so the product here will be OH, salicylaldehyde. I hope this is clear to you all. So in order to memorize these two reactions, we can clearly say that, let us say, when you are having aniline, or we can say that any aliphatic or aromatic amines which are 1 degree, and you are having phenol, both two can undergo a chloroform reaction. So we can see that the reagent is completely same. You will be having CHCl3 in the presence of KOH. You will be having The first one is the carbylamine reaction, and in the second, if phenol is reacting with this, you will be having remertiol. And the product here is isocyanide, and here salicylaldehyde. I hope this page will help you in memorizing these concepts. Is it clear, everyone? Shall we move to the next part? Okay. Now, we will be dealing with the reagent portions. Okay. Now, the next portion of this chapter, we are dealing with some kind of reagents. Okay, very good, Ananya. Okay. In this part, we will be dealing with the reagent portions. So before dealing with this question, shall we go to the, shall we make a list of the reagents, and the reagents will attack to the which of the substrates, so that the whole list will be compiled up. Okay, let us try to build it up. So before going to the reagent portion, we should be known about it. What is the electrophilicity order? Order of the carbonyl compounds, or we can say that it's like compounds. So what is the electrophilicity order? Now we will be understand. It means more the electrophilic nature of any compound or group, the more will be the rate of reaction for the nucleophile to attack over it. So let us make a list over this. The first and the foremost thing is amines, NR2 positive. This is a very electrophilic. Then you will be having acyl chloride, then aldehyde, then ketones, then ester, then we can say that amines, or we can say that before it you can write it in the form like OH, then amines. This is the electrophilicity order of the compounds. So if you guys are aware about it, then we should go to the nucleophilicity order. And when there will be the nucleophilicity order and the electrophilicity order, so more the electrophilic compound is, the more the nucleophilic compound is, the reaction in between them will be having the more rate of reaction. Okay, let us go to the reagent portions. Okay, we will try to make a list over this. Let us see. You are having reagents in that portion. Let us say you are having NaBH4. Next reagent is LiBH4. The next one is ZnBH4. Okay, twice. This is the reagent you can skip. But if you are making the list, you can try to remember this reagent as well. Now, after this, you will be having LiAlH4. Again, we can write the electrophilicity order over there. The first one is iminiamine, NR2 positive. Then you will be having acyl chloride, or we can say that any chlorides, aldehyde, ketones, ester, and we can say that acid. This is the electrophilicity order of the compounds we have already done. Sir, is this portion is in class 11th? chemistry because I'm in class 11th. No, this is not in the 11th class, but you can try to build up the concepts. It will help you in moving the class 12th. Okay, so let us try to go over there. So the NaBH4 is having the less nucleophilicity. So what will it undergo? NaBH4 will only get reduced, or we can say that hydrogen will attack to this position and will form amine on this. It means it will react with this, 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 and this. Ester and acids will not be covered by this reaction. Okay. Now, in LiBH4, it can undergo a reaction with ester as well. No, no. So it will undergo a reaction with ester. Acid will not react with it. In ZnBH4, it will undergo with everyone. And in last LiLH4, we can say that this is highly more reducing agent. We can say that. So this will undergo a reaction with everyone, including amide. Including amides. I hope this table will help you in clearing your doubts regarding the reagent portion. So let us get back to the why LiBH4 will gonna attack, or we can say that reduce the ester portion. It will not reduce the acid portion. What is the difference between NaBH4 and LiBH4? Let us say that if you are having, let us say if you are having O, OR and aldehyde, we can, let us take an aldehyde over there. If you are reacting with LiBH4 and NaBH4, clearly NaBH4 is having a less nucleophilicity, or we can say that the hydrogen of this will not gonna attack to the ester position and will not go any kind of reactions. So there will be no reactions. But in case of LiBH4, what will it go? It is having the same nucleophiles, a BH, and here it is also a BH. So there will be the role of, we can say that, cations. There will be the role of cations over here. So what will be the lithium will undergo? Lithium will bind with this oxygen lone pairs and will chelate it. We can say that it will show Li positive negative, which make it more electron deficient. We can say that more electrophilic. So now this BH will easily undergo reaction and you will be having C double bond O and H, then it will further reduce to OH. I hope this concept will help you in deciding this table formation. What will be the table here? See here. The ester will not be reduced by NaBH4, but it been reduced by LiBH4. This concept you will try to help in making this kind of tables. Is it clear? Okay. Get back to the question part. And the question will be about dibalage. So now again the new concept will be better. So firstly, we will be discussing about the dibalage. What is dibalage? Can anyone give me the full form of this reagent? Or we can say that. What does dibal stands for? Anyone? Okay. So in dibalage, I will be making the structure of this. Meanwhile, you can write it. The structure of dibalage is like this. There will be the aluminium, hydrogen. This is the structure of dibalage. No. There will be no diboranes, aluminium hydride. can clearly say that this group is isobutyl group. This group is isobutyl group. So we can say that there will be two isobutyl groups. So diisobutyl aluminium hydride and we are writing in the form like ALH isobutyl की twice. Absolutely correct. Diisobutyl aluminium hydride is a full form of this reagent. Okay, and always remember, diable H reactions will undergo at very low temperature. We can say that minus 78 degrees centigrade. And at this temperature, we can say diable H is contractor of aldehyde. Contractor of aldehyde, diable H at minus 78 degrees centigrade can be known as contractor of aldehyde. It means whatever the reagents you are using, whatever the substrates you are taking, you are using the diable H at minus 78 degrees centigrade, you will be always landed to the product of aldehydes. Always remember. We can say that if we are taking the reagents such as we are taking R, C triple bond N, you are reacting with diable H. So what will be the case? Now this aluminium hydride bonds will undergo a reaction. It will react over here and you will be having R, C double bond N, यहाँ पे Al any complex and will be the hydrogen. There will be the positive. And now this amine will form. This is the first, and at the second position you will be adding H3O plus. And on hydrolysis of this amine, you will be having H3O plus, you will be getting aldehyde. This will be the product. Is it clear to everyone? Or we can say that if you are taking a reagent called, substrate called ester, you are reacting with the diable H at the very first instant, and at the second position you will be hydrolyzing it. You will be having this product. We can say that the aldehyde is the final product of these reactions. But always remember, the temperature is to be maintained at very low. If you are raising the temperature, there will be the possibility. So there will be the possibility of the formation of alcohols as well. It means this aldehyde can further be reduced, or we can say that reduced to alcohols at relatively higher temperatures. So will every student get intensive test series? You can contact to your respective batches. You can surely get it. Is it clear? So we can say that, or we can summarize it in the form like, if you are having R, C triple bond N, or we can say that R, C double bond OR, you are reacting with diable H, you will be having R, C double bond OH. This will be the product formation. Is it clear? This is what you can memorize it. On relating with the reagents, or we can say that the electrophilicity order we have already done. I'm giving you just a question which will help you to memorize each and every one reagents along with the nucleophilicity order you have to memorize before dealing with this question. Okay, let us start with that question. Let us try. You are having this OR, OH. You are reacting with, let us say, NaBH4, second part LiBH4, at third LiAlH4, and the fourth BH3. What is the product formation? Or we can say that we can mark it as A, B, C, and D. So what are the products formation in that portion? Try to solve it, then we will be discussing each and every point. Okay. As we have already undergo that, NaBH4, we can say that beforely we have make a table. Just a second. Yes, NaBH4 will only get been, it will not get reduce the ester portion. It will not reduce the ester, but NaBH4 can also cannot reduce the acid portion. But LiBH4 can always undergo reaction with ester and will not undergo reaction with alkyl acids. Okay, always remember. So with the help of this table, we can surely do this reaction, which is now here. So if we are reacting with NaBH4, you are having this substrate. You are reacting with NaBH4. So no reaction will occur. Why is it so? Because both ester as well as acid will not be reacting with NaBH4. Okay, so NaBH4 will not be the case. So if we are reacting with LiBH4, so what will be the case? LiBH4 can reduce only the ester portion and will not reduce or will not touch any kind of acid. So what will you get? You will be having C double bond O, OH, and it will reduce to alcohol. You will be having alcohol over. Is it clear? Okay. Now, if you are reacting with LiAlH4, this is very special because it is very strong reducing agent. It can reduce every reagent. The first one is acid will reduce to alcohol as well as ester will reduce to alcohol usually. So what will you get? You will be having OH as the final product. Okay, and the last reagent we are having BH3. BH3 is not like these kind of reagents. These reagents are nucleophile based, but the reagent BH3 is electrophilic in nature. We can say that this is electrophile. So in order to carry out this reaction, it will undergo with that reagent which is very less electrophile. We can say that very much electrophile means it will react with acid and it will not react with ester. So what will you get? You will be having C double bond O, OR, OH will be formed, and we are taking as one equivalent. So this is the whole scheme of the reagents we have already done. I hope this portion is clear to you all. Is it? Okay, let's back to the question part. What does the question suggest? Yes, we are dealing with this portion. We are reacting with dibyl H. What will you get? Dibyl H will reduce, or we can say that dibyl H will convert cyanide, or we can say the aldehyde. Dibyl H is a contractor of aldehyde, so it will transform directly C into CHO, and the other substituents remain same. The other substituent remains same. So what will be the product? I hope option number 1 will be the correct answer. I hope this question is clear to you all. And always remember, from this session, you can expect minimum 2 questions in your final NEET exam. Is it clear, everyone? Shall we move to the next question? Okay then. Okay, now we will be having question number 77. In this question, there will be a presence of ether. We can say that when phenol is heated with HI, the product formed are. In this question, there is a clearly mention of the substrate. So if it is not mentioned, you should be aware about the term pheneton. Pheneton is, you have already aware about it, it's OCH2CH3. This is pheneton. And if you are reacting with HI, you are reacting, we can take it on the another slide. You are having OCH2CH3, you are reacting with HI. So what will be the product formation? We have done in the previous session as well. What will it be? So directly, the lone pairs of this will take in proton from here, and you will be having an acidic CH2, CH3. This will be having the positive charge over here, and there will be the presence of I negative. What will I negative will undergo? So this bond will not be cleaved. This bond will not be cleaved. So the only option with I negative to undergo an SN2 reaction, and it will move over here and will release back to it. You will be having OH plus CH3 CH2I. This is the final products of the reaction. Is it clear, everyone? And I have discussed the cleavage of ether bonds in the previous sessions. You can surely go and visit them, and you will get a better understanding for these questions. Is it clear, everyone? Is it? Okay, so we are having the phenol and ethyl iodide must be the correct answer. So shall I give you an question as the time permits us? So we are having, let us take a question so that you guys will be more comfortable about the things we have already done now. Let us say you are having OH, you have taken NH2 and you are reacting it with what will be the product formation? And you are taking it in excess. What will be the product? Can anyone? we can clearly say that this is a phenolic portion, this is 1 degree amine, and you are reacting with chloroform in the presence of alkali. It means in this portion, absolutely correct, because in this portion you will be having both reactions. You can say that this reagent can undergo both the carbylamine test as well as Riemann-Tiemann reaction. So you will be having the product called this. OH and CHO. Here you'll be having NC. It's NC. Always remember, I will try to make it more clear. Here both carbylamine reaction as well as Riemann-Tiemann reaction will take place. Is it clear, everyone? Okay. So let us deal some common names. I think these can be asked, or this can be very helpful for you. We can learn with a trick called, let us say, you are having so what is the common name of this compound? Can anyone? I'm not getting into the IUPAC name. I want a common name of this reaction. Or we can say that the question number 1 and the question number 2 is COOH, COOH. You all are aware that this is an oxalic acid. So what is this? What is the common name of this substrate? And you must be heard about some names called adipic acid, palmitic acid, or gluconic acid, malonic acid. Is it? So let us discuss some reagents called, let us say you are having oxalic acid. This is oxalic acid. And if I am adding a CH2 position, CH2 group in between them, you will be having COOH, CH2, COOH. This is malonic acid. Try to learn this. And at last of this portion, we will be having a trick so that you guys will remember all the names here. Okay, this is malonic acid. If you are adding one more, this is succinic acid. If you are adding one more CH2 in between them, glutamic acid. And if you are adding one more, we can say that this is adipic acid. If you are adding one more CH2, 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 COOH. So in order to learn this, you should be having one mnemonic called Ohm's gap. It it will be very helpful for you. It means if you are having COOH, this is, we all are aware about this. This is oxalic acid. It means when you are adding one CH2 in between them, let us say you are having COOH, CH2, COOH. This is malonic acid. You are adding one more CH2, you will be having succinic acid. You will be adding one more CH2, glutamic acid, then adipic acid, then glutamic acid. So this is a trick which will be very helpful for you in order to understand or in order to learn the common names of the compound. Is it clear, everyone? Is it clear? I hope this session will be very clear to you all. But before the session end, I'm just giving an homework so that you guys will attempt that portion. Okay? So let us write in question. Let us say you are having you are reacting with LiBH4 and you are reacting with BH3, or let us replace it by NaBH4. So what will be the product formation? Here it is A and here it is B. You can write in the comment section that which functional group will be reduced by which of the reagent. Is it clear? If you guys have no kind of doubts, so thank you so much for joining this class. We will meet you in the next session. So thank you so much.